Hi, my name is Brendan Kenny. I'm with the Maps Developer Relations team, and I'm here to talk to you about using D3.js to drive the geometry that lives on top of your Google map. So D3, if you aren't familiar with it, is becoming a wildly popular data visualization library, and it's brought to you mostly by Mike Bostock. Here we can see, a bunch of examples. So the great thing about D3 is there's just tons and tons of examples, all with code to let you know how to do them. And a big part of this, part of D3 has been geo application. So using geographical data and doing visualizations with this geographical data. So for the most part, it seems like D3 lives separately from something like a maps application. But really, all it does is takes data and binds it to some way of displaying that data. That's kind of the just underlying thesis of D3. Data-driven documents is what D3 stands for. And so we can take advantage of that to use kind of D3 skill sets and the tools that D3 brings and put it on top of a map so that you can put things in place. So we're going to start with a really simple example just to show how this kind of binding to the Maps API works. So here's a cool example that's been highlighted recently by Mike, and it has to do with scale-dependent sampling, as it says on screen, using the kind of scale of the thing that you're displaying and the amount of precision that you need to show at that scale to resample a line so that you get a smooth curve. And you can see here that we have these control points multiply as you zoom in so that you get a really nice smooth curve. But as you zoom out, it starts eliminating these control points so that you don't draw too many of these line segments, filling in pixels that you would never see in the first place. And so we're going to use that and bring it over to this example. So here, all I've done is taken that same exact thing. I've removed the animation just so it's slightly less distracting. And whereas this is some tricky projection, this is just a really simple Mercator projection. And I've taken a line, and all I'm doing is saying, show me a line that kind of undulates around the equator. And if you want to see what that looks like, it just looks like this right here. I'm just defining a line string kind of in this GeoJSON-like format. And I'm keeping it right on around the equator. So here's 20 degrees north, past the equator, 20 degrees south, and back again. And then it just rotates around the Earth. And so the key thing here is actually we only have 5 points, really 4. It begins and ends at the same point. But D3 knows that you want to draw a great circle, and so it actually fills in and smooths that curve for us. So that's great. It's now in a different projection, and that's a great thing about D3 is that you can throw any projection in the world at it. But really, we want to bring this into Google Maps. So how do we do this? So the way that D3 renders paths, the way that most examples of D3 render paths either falls down to SVG or Canvas. So these are the two kind of newer browser technologies, newer browser technologies that let us draw things dynamically. So each brings its own benefits. So SVG lives in the DOM. You can add mouse events to it. You can select things after the fact and do logic on that sort of thing. Whereas Canvas, it gets rasterized, puts into display, but then you get really fast display if you have maybe thousands or millions of elements. And that's what lets you do WebGL. You can rasterize to an image and put it on screen, and even if it's a huge amount of elements that you could never put in the DOM. So each has its trade-offs. But really, it's actually abstracted. There's actually an interface that D3 uses to write to these different graphics contexts. And there's different methods that it uses that lets you bind SVG or the canvas to the thing you want to display. In this case, a path. We want to draw this red path. So we're going to use the canvas kind of method of binding these things because it's a little bit easier. So if you dig into the D3 docs, you can go to d3.geo.path here, and if you look, we can where are you? There we are. If you look, we can see path.context. So This is actually used in that code that we were looking at, where we create a path from that, that line around the equator. And then when that path is being created, actually, we have a context that we pass it to draw to, sort of. If you just look at the code afterwards, you'll see what I mean. But you pass it a context, and it binds to that context. But if you look at these docs, it doesn't actually have to be a canvas context. All it has to do is fulfill a certain interface. And here are the following methods that you have to fulfill if you're implementing that interface. So you begin path, move to, line to, arc, and close path. And so if you've ever used HTML5 Canvas, those should look very familiar. Those are like the basic drawing tools. And it allows you to construct paths. And then once you have that path kind of in your context state, you can either stroke it or fill it. But there's no reason, again, that this has to be a canvas. It's just an interface. And we can actually fulfill that ourselves. And if you look, there's actually scattered throughout examples, you'll see places where they cheat. And they actually pass a context in to buffer objects into an array, for instance, and then pass that array to a different way of rendering. So that's what we're going to do. We're going to cheat, and we're going to implement this context in terms of the V3 Maps API geometry methods. So let's go back to the code. And I've created this really simple thing called the polyline context. And it's about as dumb as you can get. And it relies on the fact that in this case, we know we have just a line, so we don't have to worry about polygons, for instance, that might have breaks with different polyline rings that we then need to fill. And we don't have to worry about arcs. We know that it's never actually going to call arcs, because we would be in trouble if it tried to call an arc. So we've implemented these 4 methods on this polyline context, or 5 methods. And most of them do nothing. So begin path, we don't really care. It doesn't do anything. In that case, you could have made it so it creates a new polyline, for instance. The same thing with arc and close path. These are just empty functions. And in fact, they're never actually called by the path code. And then the important ones are move to and line to. And I've made a really simple method here. It's actually the same for both, where if a current path is selected, then so a polyline on the map is selected, then I create a lat long object and push that onto the polyline path array. And so if we go to the map code, we have 2 things going on here. We have first we initialize a map just like always, and in that on that map we make a polyline, and then we init D3 to do the same thing as in the previous example. But now, instead of context from a canvas, now we're doing a polyline context, the context we just made up. And when we create our path object that's with our equirectangular projection, so that we can do just like an identity projection, we pass that to the context. So now we're finally at the point when we can actually draw this. And so to draw it, we've changed our style methods that set properties on a canvas context to setting those options on the polyline. So we have a red and a stroke weight of 2. And then we set our current polyline, that's part of the polyline context that we wrote. And finally, we just pass it to this path method that we created up here. And that projects those points and then passes it to the context through those 5 functions, or really 2 in this case. And just calls point, 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 point. And so finally, we can take a look at what that looks like. And if we refresh, you can see that we have this line. And in fact, let's make it a little thicker, just so it's a little bit more obvious. You can see this path that we've created. And so we're actually using the D3, all its different machinery, and then driving these points on the map. So this could be anything. So in this case, I created a simple GeoJSON in code. But you could bring that GeoJSON in. You could use TopJSON, which is natively supported by D3. You can use any sort of thing and pass it in and to draw these draw commands. And then just like we drew these polylines, we can also draw polygons, that sort of thing. You just have to be careful with your context. And so just as a last really simple example, we can see as we zoom in, we get these hard corners here where you see a definite angle. So we're not adaptively resampling. And so we can actually do a couple of things there. We can tell that D3 that the scale has changed, or we can totally cheat and go to the console here and just set set the precision of the projection manually. So here we've moved to a much smoother polyline, and we can even do that. So on zoom, for instance, we could change the precision of the polyline if we wanted to do that. And it goes the other way too. We can set it so it's just like this very angular thing. And so as you can see, it's the full pipeline. It's really easy to bind, and so that's something to keep in mind in the future when you're looking at kind of, I want D3, but I also want to put it on a map if it actually needs to be in context. And so there's no reason why these can't live together. D3 is designed exactly for this kind of adaptability. So try it out. Check out the code. It's going to be in a simple gist linked on the video, and let me know what you think. And if if anything interesting comes up, we can cover it in future map shortcuts. Thanks.